All right. So, core mathematics was written. The WASI was written recently, and students were complaining that the questions were difficult and stuff. Actually, it was not difficult like that. You just need to do some thinking. You need to do some application. You need to apply. You just need to do some application, and you'll be fine. So let's see how we are going to solve the first question. All right. So the question goes: an intercity shuttle travels between two cities, Amanfro and Kotoku, covering the first half of the distance at an average speed of 60 kilometers per hour, and the second half at 90 kilometers per hour. The total distance between the two cities is 300 kilometers. Now we are asked to calculate for the entire journey the average speed of the shuttle. B. If the speed of the shuttle on the first half of the journey is reduced to 50 kilometers per hour, determine its effect on the overall time. Now, how do we solve this question? First of all, I try to sketch something. Now, we are told the distance, the total distance between the two cities, that's Amanfro and Kotoku, is 300 kilometers. Now, we are also told that the first half of the journey, the shuttle used an average speed of 60 kilometers per hour, and the second half of the journey, 90 kilometers per hour. Now, note we are talking about first half. So if the entire journey used 300 kilometers, it means the first half is going to be 150 kilometers. You just divided 300 by 2. So the first half is going to be 150 kilometers, and the second half is also going to be 150 kilometers. All right. So you should know the relationship between speed, distance, and time. Now, speed here is actually what's the name? A scalar quantity. Now, speed is just the rate of change of distance with respect to time. So there's a difference between speed and velocity. So the difference is that speed is actually velocity is a vector quantity, and speed is actually a scalar quantity, because velocity is the rate of change of displacement with respect to time, and speed is the rate of change of distance with respect to time. Now, note the difference between distance and displacement. When we say distance is just the interval between 2 points. And when we say displacement, we are talking about a distance covered by a body in a specified direction. So you see the difference between displacement and distance. So now let's continue. Now, speed is actually distance over time, which means if you make time the subject, our time becomes distance over our speed. Now, let me give you a fair idea of what to do. Now, the whole thing here, you are just supposed to find the time the shuttle used in the first half of the journey and the time used in the second half of the journey. When we get those times, we just add them, get the total time used in the entire journey. Then, if you want to calculate the average speed, you know that average speed is distance over time. So it's just going to be what? The total distance over the total time taken by the intercity shuttle to actually finish or complete the journey. So let's see the calculation. So now, the time the shuttle used to complete the first half of the journey or the distance is actually what? 150 kilometers by 60 kilometers per hour, because we know our time is distance over speed. And we are told that the speed used in the first half of the journey was 60 kilometers per hour. Now, when we solve this, for the first half of the journey, the intercity shuttle actually used 2.5 hours. That's 2.5 hours to complete the first half of the journey. Now, for the second half of the journey, what's the name? The average speed used by the shuttle was 90 kilometers per hour, which means the time the intercity shuttle is going to use to complete the second half of the journey is going to be 150 kilometers by 90 kilometers per hour. And when you do our reduction, you're going to get 5 out of 3 hours, which in decimals is 1.667 hours. Now you're picking 4 decimal places to actually reduce error, because we truncate. We are doing truncation. So when you truncate it or you leave it in 4 decimal places, it minimizes error. So now the total time used in the completion of the journey will be what? The time used to complete the first half of the journey plus the time used to complete the second half of the journey. Now when you add those time, you're going to get 4.1667 hours. Now the question asked to find the average speed of the shuttle for the entire journey, which is going to be the total distance over the total time, which is, we know our total distance to be 300 kilometers. So 300 kilometers divided by what? 4.1667 hours, which is going to give us 71.999424 kilometers per hour. Now, which is approximately, let's round it to the nearest whole number, approximately 72 kilometers per hour. Now, the next question also said, let's see, if the speed of the shuttle in the first half of the journey is reduced to 50 kilometers per hour, determine its effect on the overall time. So now, this time around, the speed used for the completion of the first half of the journey is no more 60 kilometers per hour, but rather 50 kilometers per hour, which means that that's our new average speed. So we need to also calculate the time based on the new average speed. So the time used is going to be the same 150 kilometers, because first half of the journey was 150 kilometers. So 150 kilometers by the 50 kilometers per hour, and you are going to get 3 hours. So it means based on the 50 kilometers per hour speed used by the shuttle in the first half of the journey, it used 3 hours. All right. So, but for the second half of the journey, the average speed was maintained. So you are going to use the same hours used to complete the second half of the journey based on the 90 kilometers per hour. So you need to get also the total time used as the the average speed for the first half of the journey was reduced to 50 kilometers per hour. So 3 hours plus your 1.667 hours to come out to be what? 4.667 hours. So we are also asked to let's also get the average speed for the entire journey based on the 50 kilometers per hour, because there have been some reduction in the speed from 60 to 50, which means there has been a reduction. So average speed for the entire journey now becomes 300 kilometers divided by 4.667 hours, which is going to be 64.28 kilometers per hour. So let's say approximately 64 kilometers per hour. Which means if you look at the effect on overall time, you have to subtract the overall time as when there was no reduction in the speed, minus when there was reduction in the speed. So when there was a reduction in the speed, realize that our overall time was 4.67 hours. Then when there was no reduction, it was 4.167. So it's going to be 0.5003 hours. So which is just 0.5 hours. So if you look at this carefully, you realize that the reduction of the average speed to 50 kilometers per hour increased the overall time from 4.167 hours to 4.667 hours, and also caused a decrease in the average speed of the shuttle for the entire journey from 72 kilometers to 64 kilometers, which means that the time increased as we reduce the journey, as we reduce the speed. As we reduce the speed, the time increased for the total time used for the completion of the journey increased from 4.1667 to 4.667 hours. Then the total speed or the average speed for the entire journey, as when there was no reduction in the speed for the first half of the journey, was 72 kilometers. And when there was a change, or when there was a reduction, it was 64 kilometers per hour, which means there has been a reduction in the entire or the average speed for the entire journey used by the shuttle. Thank you.